All right, so your homework in this section is going to be section 9.1, page 481. You're going to just have 7 through 19 odd to do. I'm going to go through a couple even problems just to show you what kind of thing I expect to see. Here's a number 8. It says compute the limit of partial sums to determine whether the series converges or diverges. All right, so that means we're going to look at, S sub n for, various values of n and try and compute that limit. So all you really need to do here is look at, here's my sequence 2 minus 1 plus 1 minus 1 plus 1. All right, so what is S sub 1? S sub 1 is 2. All right, what is S sub 2? It's 2 minus 1 is 1. What's S sub 3? It's 2 minus 1 plus 1 is 2, and so on. All right, so now I get the idea of what S sub n is, and what I can see just by looking at it, so just by inspection, the limit as n approaches infinity of S sub n does not exist. Therefore, the series diverges. All right, so this is establishing that conclusion from the sequence of partial sums, which is what they ask you to do. Of course, by the way, you can also conclude that since the limit as n approaches infinity of a sub n also does not exist, because we're just alternating between 1 and negative 1. Right, this is what a sub n is doing, not S sub n, but a sub n is like doing this. So a sub n, the limit is not equal to 0. Limit as n approaches infinity of a sub n is not equal to 0. In fact, it doesn't exist. So the series diverges. And here's how we're going to use that nth term test as a justification by nth term test. So now this right here is just sort of an optional look ahead. This is what they're asking you to do in this particular set of directions. All right, so let's look at number 10. So number 10, from the same section, same directions, you have 3 plus 0.5 plus 0.05 plus 0.005 plus, etc. All right, so it says to look at the sequence of partial sums. There's a lot of other different things we could do. But the directions say look at compute the limit of the partial sums. So S sub 1 is 3, S sub 2 is 3.5, S sub 3 is 3.55, S sub 4 is 3.555. And we can see that the limit as n approaches infinity of S sub n is equal to 3.5 repeating. And all they've asked us to do is determine whether the series converges or diverges. So since the limit is a finite number, so the series converges. And that's all they've asked you to say for this, all right? But by the way, we can say quite a lot more, right? Because we can say that, that this is equal to 3 plus the sum from n equals 1 to infinity of 0.5 times 0.1 to the n minus 1, right? So what I've done is and this is a typical thing to do, I've split off a certain finite part, and then I've just said, okay, what's our real infinite sum here? It's the 0.5 things. So a sub 1 is 0.5, there's our a sub 1 is 0.5. I'm multiplying by 0.1 every time, so 0.1 to the n minus 1. So I can set that up as a geometric series. So this is geometric with absolute value of r is equal to absolute value of 0.1 is equal to 0.1 is less than 1. Since absolute value of r is less than 0.1, this sum is equal to, so let's just put an equals here, we'll bring down the 3, plus our a sub 1, which is 0.5, over 1 minus r, which is 1 minus 0.1, so that's 3 plus 0.5 over 0.9, it's 3 5/9. That's what this, so that's what this repeating decimal is, also 3 5/9. So there you go. All right, what else can we do? So let's look at a couple more here, like number 12. So in number 12, number 12 doesn't say the limit of partial sums. It says tell whether the series converges or diverges. If it converges, give its sum. Okay, so how are we going to do that with number 12? So number 12 says 1 minus 2 plus 3 minus 4 plus 5 minus blah, blah, blah. And then it gives you sort of a little bit of a hint by saying the nth term is given by negative 1 to the n times n plus 1. And you can sort of think about how this generates that sequence. It's important to think about things like that. All right, so then what I would look at this and say, the first thing you should look at is the limit of the terms of the sequence. The limit as n approaches infinity of a sub n does not exist. All right, so it's not just infinity, by the way. So this is an interesting sequence that diverges to two different infinities. So, if I look at, 1, -2, 3, -4, 5, -6, right? The series is diverging, but not toward infinity or positive infinity. It's diverging schizophrenically toward both infinities. So we can't say the limit is infinity or negative infinity. That limit does not exist, the limit of a sub n. All right, so, and now this is where properly we should say this. The series diverges by nth term test. What does nth term test means? It means if this limit as n approaches infinity of the terms is not 0, then the series diverges. That's all we can say about it. All right, so how about number 14? So number 14 has a sum from n equals 0 to infinity of 2/3 times 5/4 to the n. Well, what can I say about this one? All right, I can say that this series is geometric with r equals 5/4. So I can see that right there. Okay. Now I can just say 5/4 is greater than 1, but remember the theorem is more specific than that. The theorem is that absolute value of r has to be greater than 1. So absolute value of r, here's what I'm going to say to justify this fully. Absolute value of r is absolute value of 5/4, which is 5/4, which is greater than 1. A little bit of a around the bush way to say it, but it really, nails that absolute value of r is greater than 1. That's what we need to have the series diverge. So the series diverges because we have the theorem that geometric series with absolute value of r greater than 1 diverge. Pretty handy, that. All right, let's look at number 18. See how quickly we can dispense with these summations. So number 18, we have 1/2 plus 2/3 plus 3/4 plus 4/5. It might be a little bit hard to get a handle on whether this is converging or diverging, but you can pretty much see that the fractions are not going to 0, right? They're going to 1. And they gave us that hint that the nth term is n over n plus 1, which you should be able to figure that out anyway. All right, so what are you going to say about this? You're going to say, what is the limit of the terms? The limit as n approaches infinity of a sub n equals, well, let's go ahead and be specific that it's the limit as n approaches infinity of n over n plus 1, which is 1, which does not equal 0. So the important thing about this limit is not that it's 1. The important thing about the limit is that it does not equal 0. So since it does not equal 0, so the series diverges by nth term test. And we'll look at just a couple more in the next video, and that'll be it.